For centuries, humanity gazed at the stars, wondering if other worlds existed beyond our own. Today, that wonder has transformed into discovery. We now know that our galaxy, the Milky Way, is teeming with planets orbiting distant stars. These exoplanets are not just theoretical concepts, they are real, diverse, and often incredibly strange. Each new discovery challenges our understanding of planetary formation and the very definition of a world. Join us as we explore some of the most bizarre and mind-bending exoplanets ever found. An exoplanet is simply a planet that orbits a star other than our Sun. The first confirmed exoplanet orbiting a Sun-like star was discovered in 1995, a gas giant named 51 Pegasi b. Since then, our detection methods have become incredibly sophisticated. We've found thousands of these distant worlds, using techniques like the transit method, where we observe a dip in a star's brightness as a planet passes in front of it. We also use the radial velocity method, detecting the tiny wobble a star makes as a planet's gravity tugs on it. These methods have revealed a universe far more varied than we ever imagined. Imagine a gas giant like Jupiter, but orbiting incredibly close to its star, sometimes even closer than Mercury is to our Sun. These are the hot Jupiters, and they are among the most common types of exoplanets we've found. Their proximity to their stars means extreme temperatures and bizarre atmospheric conditions. Take HD 189733b, for example. This hot Jupiter is famous for its deep blue color, but don't let that fool you. Its atmosphere is believed to rain molten glass sideways at thousands of miles per hour. The winds are supersonic, and temperatures soar to over 1,800 degrees Fahrenheit. Then there's WASP-12b, a planet so close to its star that it's being slowly ripped apart. Its shape is distorted into an egg, and its atmosphere is being stripped away, forming a glowing halo of material around its star. This planet is literally being consumed, a cosmic death spiral playing out before our eyes. What if a planet wasn't made primarily of silicates and iron, like Earth, but of carbon? Such worlds, known as carbon planets, could exist, and one candidate is 55 Cancri. This super-Earth is about twice the size of our planet and 8 times its mass. Scientists believe that a significant portion of its mass could be carbon, possibly in the form of diamond. Imagine a world where the very ground beneath your feet, or rather, beneath your spacecraft, is a giant, glittering gem. The extreme pressures and temperatures on such a world could indeed forge vast quantities of diamond. While we can't confirm it's a solid diamond planet, the possibility is tantalizing. It challenges our assumptions about the common building blocks of planets and suggests that some worlds might be incredibly valuable, at least in terms of their material composition. Some exoplanets orbit so incredibly close to their stars that their surfaces are perpetually molten. These are the lava worlds, and they are truly hellish environments. Kourou 7b is a prime example, a rocky exoplanet just slightly larger than Earth. One side of Kourou 7b is permanently facing its star, locked in a tidal embrace. This day side is a blistering inferno, with temperatures reaching thousands of degrees, hot enough to melt rock. The entire surface is likely a vast ocean of bubbling, glowing lava. On the night side, temperatures plummet, potentially forming solid rock and even rain made of vaporized rock that condenses and falls. The transition zone between these two extremes would be a chaotic landscape of constant geological upheaval. It's a world of fire and brimstone, a testament to the extreme conditions possible in the cosmos. Not all planets orbit stars. Some worlds are gravitationally unbound, drifting through the vast emptiness of interstellar space. These are rogue planets, and they are truly cosmic nomads. They might have been ejected from their birth systems during chaotic early stages of planetary formation, or they could have formed directly in the interstellar medium. One such example is PSOJ 318.5-22, a gas giant about 6 times the mass of Jupiter. It floats alone, without a parent star to illuminate it. These rogue planets are incredibly difficult to detect because they don't transit a star or cause a star to wobble. Their existence challenges our traditional definition of a planet, as they don't fit neatly into the star-orbiting category. Yet, they are worlds nonetheless, silent wanderers in the cosmic dark, potentially harboring internal heat that could sustain subsurface oceans, raising fascinating questions about the possibility of life in unexpected places. While Earth is a water world, some exoplanets might be entirely covered in incredibly deep oceans, far deeper than anything found on our planet. GJ1214b is a prime candidate for such a water world or ocean planet. It's a super-Earth with a thick, steamy atmosphere. Scientists believe that a significant fraction of its mass is water, possibly existing in exotic forms of ice due to the immense pressures at the bottom of its deep oceans. These aren't the ice cubes you find in your freezer, they are high-pressure ice phases that can exist at incredibly high temperatures. Such worlds could have oceans hundreds or even thousands of miles deep, creating environments unlike anything we know. The sheer volume of water could lead to unique geological and chemical processes, potentially even supporting forms of life adapted to extreme pressure and darkness. Many exoplanets, especially those orbiting red dwarf stars, are tidally locked. This means one side of the planet perpetually faces its star, while the other is in eternal darkness. The result is a world with extreme temperature differences, often called eyeball planets. The day side is scorching hot, potentially with a permanent ocean or even a molten surface. The night side is frigid, locked in perpetual ice and darkness. Between these two extremes lies a narrow band of twilight, where temperatures might be just right for liquid water to exist. This terminator zone could be the only habitable region on such a planet, a thin strip of twilight where life might cling to existence. The winds would be ferocious, constantly trying to equalize the extreme temperature differences, creating a dynamic and alien landscape. Imagine a sunset where not one, but two or even three stars dip below the horizon. Planets orbiting multiple stars are not just science fiction, they are a reality. Kepler-16b is a famous example, a gas giant orbiting a binary star system. From its surface, if it had one, you would see two suns in the sky, one orange and one red. The gravitational dance in such systems is complex, making the orbits of these planets fascinating to study. Sometimes, a planet might orbit both stars, like Kepler-16b, or it might orbit just one star in a wide binary system. These Tatooine-like worlds, named after Luke Skywalker's home planet, demonstrate the incredible variety of planetary configurations possible in the universe. They challenge our Earth-centric view of a single star and a family of planets. Our journey through strange exoplanets is far from over. With new telescopes like the James Webb Space Telescope, we are gaining unprecedented insights into the atmospheres of these distant worlds. We're beginning to detect the chemical fingerprints of gases, searching for signs of potential habitability or even biosignatures. Future missions will continue to push the boundaries of our knowledge, allowing us to find smaller, more Earth-like planets and characterize them in even greater detail. The more we look, the stranger and more wonderful the universe reveals itself to be. From planets raining glass to worlds made of diamond, from lonely wanderers to those with multiple suns, the exoplanets we've discovered are a testament to the universe's boundless creativity. Each new find expands our cosmic imagination and deepens our appreciation for the sheer diversity of worlds out there. These strange exoplanets remind us that our own solar system, while beautiful and unique, is just one tiny example of what's possible. The quest to find and understand these distant worlds is one of humanity's most exciting scientific endeavors, promising even more astonishing discoveries in the years to come. The universe is vast, and its wonders are truly endless.